So on page 2, we can see that we are trying to find the domain of each of these rational functions. So I'm going to do a couple with you, and then I'm going to have you try 2 on your own. So to find the domain of rational functions, your first step is going to be to look at the denominator. So for number 1, you look at the denominator, and the denominator can never equal 0, because whenever the denominator of a fraction equals 0, the entire function won't work because you cannot divide by 0. So your whole goal is to figure out, okay, what number will make the denominator equal to 0, and any number or numbers that will do that will make that domain not work for that particular number. So because 4 does not have a variable, there is no number that will make this not work, which means the domain for this one would be all real numbers. There will be no break in the graph. There will be no point where the graph will not work. The domain, the x values, will be any number. So you can either write it out like that, or using interval notation, it would be anything from negative infinity to positive infinity. Okay. Okay, no problem. All right, bye. And then for number 2, we're looking here at the denominator to see when the denominator will equal 0, and I see x squared minus 4. Whenever you have a denominator that looks like it can be factored, that should be the first thing you go to do. So we want to figure out when x squared minus 4 will equal 0, but before we actually solve that, we should factor it. So x squared minus 4, we want to see when that is equal to 0. And in order to solve that, one way to do it would be to factor it. Well, this is a perfect square. X squared is a perfect square. 4 is a perfect square. This is a difference of squares, which means you can factor this into being x plus 2 times x minus 2. Since 2 times negative 2 is negative 4, and 2 plus negative 2 equals 0, you can factor x squared minus 4 into x plus 2 times x minus 2. And then what you will do is set both of these parts equal to 0. So you'll set x plus 2 equal to 0 and x minus 2 equal to 0. Solve them both separately. When you subtract 2 from both sides, you're going to get negative 2 for this one. When you add 2 to both sides, you'll get x equals 2 for this one. That means whenever x is equal to 2 or negative 2, the denominator will be equal to 0. Because if we have this function here, if we have, let's say, positive 2 in the denominator and the numerator, x squared minus 4. So if we put in a 2 here and a 2 here, this will be 5 times 2, which is 10, and the denominator will be 2 squared is 4, 4 minus 4 is 0. This would be 10 over 0. It doesn't work. Also, if it's negative 2, it's not going to work because 5 times negative 2 is negative 10. And negative 2 squared is negative 2 times negative 2, which is also positive 4. 4 minus 4 is 0. Negative 10 divided by 0 will not work. That means that the domain is every number but negative 2 and 2. So I would write that just as x cannot equal negative 2 or positive 2. So when you're trying to find the domain for these functions, you look at the denominator of the function, and the denominator can never equal 0. So what's interesting about that is that to find out what numbers that would be, you would actually set it equal to 0 and solve. If it can be factored, you should then factor it to solve. If it can't be factored, then you should be able to just solve that equation the way that it is. So I want you to go ahead and try numbers 3 and 4 on your own. And then in a few minutes, we'll go over the answers, and then we'll move on to the next example. anyone need any help? All right, so the domain is whenever the denominator will not be equal to 0. So to do that, you will look at what the denominator is and set that equal to 0 to solve for whatever the denominator will equal to 0. Once you have that number, that is the only number or numbers that will not work for the domain. So the domain would be every number but those numbers. Since this one's just x minus 3 and it can't be factored, you would just solve this. And we would have here that the only number that would make the denominator equal to 0 is when x is equal to 3. That means the domain for this, I'll just abbreviate, the domain for this would be any number but 3. So the answer would be any number but 3. The only number that would make this function not work is when x is equal to 3. So that's why the domain would be anything but 3. For number 4, this is going to take a couple more steps because when I look at the denominator, x squared minus 5x plus 6, and I am trying to figure out when this is equal to 0. This has to be factored in order to solve this. So when I go to solve this by factoring, this is a 1 here, so I'm trying to figure out what multiplies to be 6, positive 6, and also adds to be negative 5. Hopefully this factoring part is coming quickly to you and this is not a struggle. The two numbers that this would be x minus 2 times x minus 3. So once I have it factored, then I can use the zero factor property to separate them both into two little equations, x minus 2 equals 0 and x minus 3 equals 0. I solve both of these equations, and I'm going to get two numbers that will not work for this function, and it's when x is equal to 2 and when x is equal to 3. That means that the domain is every number except for 2 and 3. Every other number will work for this problem except when x is equal to 2 and when x is equal to 3. So what's interesting about finding the domain for these numbers is it's almost the same exact process as like the last section we learned in chapter 5, in that you're solving these equations that equal 0, and then you get all the way down, you get the answers, but the only thing you then have to apply is that means that the domain can't be, it'll be everything but these numbers. And the whole goal for this is to figure out when the denominator equals 0. Sometimes, well most times, you can factor it, but sometimes you can also solve it with algebra. So I do want to quickly just go back to number 2 because I realize that there are some web assign problems, and sometimes things like this happen. I want you to realize that you can factor, but you can also do something else. So let me go back to number 2. So number 2 says 5x over x squared minus 4. So we want to see when x squared minus 4 is equal to 0. Now, if I just gave you this problem and I said solve for x, probably the first thing you would do is not factor it. You probably would be thinking, okay, let me add 4 to the other side and see what happens. And you have here that x squared equals 4. I know we really didn't get to solving these types of problems yet, but I do want to show you that this is another way you can solve this if this particular type of problem happens. In order to undo a square, you can take the square root. So when you take the square root of numbers and you take the square root of 4, that means what number times itself equals 4, and there's two numbers that do that. 2 times 2 equals 4, and also negative 2 times negative 2 equals 4. Sometimes you'll be seeing the numbers listed like this, like plus or minus 2. And that means that it's either positive 2 or negative 2. So I do want to show you this as well, so you know that you can also solve the problems if they end up being like that in number 2. Number 4, though, you can't do that because if you went to solve this, it's not just like x squared equals a number. If it ends up being like this, it's technically a difference of squares, which means it's just the positive and negative version of that number. It only happens for this type of problem. So that's finding the domain of rational functions. In the next section on page 3, now we are going to simplify rational expressions, which really connects everything we learned in chapter 5 to this new topic with having polynomials in the numerator and denominator. So to simplify a rational expression, you find all the common factors of the numerator and denominator, and the common factors can be constant numbers. They can be monomials, like meaning they're constant numbers and variables, or they can be binomials. It really depends on each situation. So we're going to do A, B, C, D together, and then you're going to try these problems on here to the right. So in these examples, your whole goal is to try and simplify this as much as possible by taking out as many things as you can in the numerator and denominator, and you're kind of doing that by factoring. So you have to look at these rational functions in both the top and the bottom and kind of figure out, okay, what can I take out from the top and the bottom? Before, when you were factoring, you were only looking at one particular problem and you were thinking, what can I take out of this one completely? Now, you might not be factoring both parts completely. Now you're looking at both of them together and you're figuring out what can I take out of both, which might not be the greatest common factor of just the numerator or the denominator. Hopefully what I'm saying is making sense. So before, if I said factor 18x squared y, you might be thinking, well, I can't really factor that. And now you're going to be looking at 18x squared y compared to 15xy to the fourth. So you're looking at two separate parts at the same time. So I like to first start with the coefficients, 18 and 15, and you're trying to think of the biggest number you can take out of both, and that would be 3. So I'm going to take this fraction, and I'm going to take a 3 out of the numerator and denominator. And then looking at the x squared y on the top and the xy to the fourth on the bottom, the greatest common factor of both the numerator and denominator would be 1x, since I can take an x from both the numerator and denominator, and 1y. So what I'm going to do is take 3xy and factor it out of the numerator and the denominator, because whenever you have the same thing in the numerator and denominator, it can actually cancel out. So when I do that, I'm going to be left with stuff inside of parentheses to still keep it equivalent. So if I take a 3 from 18, I would have a 6 left. If I take 1x from x squared, I have 1x left. And if I take the y out of y, there's really nothing left. So this is too much space, but I have 6x left here on the top. And then on the bottom, if I take a 3 from 15, I have 5 left. If I take the x out of only 1x, there's no x's left. And if I take 1y from 4, I have y to the third power left. So what I did was I looked at the numerator and denominator separately, but at the same time together, and I tried to figure out what I could take out from both parts. And it was 3xy. I did that because whenever you have the same thing in the top as you do in the bottom, they cancel out. This simplifies to be 6x over 5y to the third power. These problems are asking you to simplify rational expressions. These problems could also then have a second part and then say, what is the domain, which then you would be looking for when the denominator is equal to 0, but it's not asking that in this particular set of questions. It's just asking you for you to simplify. All right, in letter B, we are now taking this expression and trying to simplify it as much as possible. What's confusing about these problems is sometimes you're not taking the full greatest common factor out. Sometimes you're only taking out the biggest number of things you can from both the numerator and the denominator. So you can look at all the parts in the numerator and denominator together and figure out what's the GCF of all of those things. So let's start with the coefficient numbers, 2, 6, and 6. I can take a 2 out of all 3 of those numbers. So in my numerator and denominator, I'm going to take a 2 from both. And then let's look at the x's. I have x to the third power, x to the first power, and x squared. I can take one x out of all of those. So I'm going to take an x out of the top and the x out of the bottom. Then what I'm left with on the top, will be x squared minus 3. And you can just verify that by quickly multiplying it out. 2x times x squared is 2x cubed. 2x times negative 3 is negative 6x. And then in the denominator, if I take a 2 out of the 6, I'm left with 3 here. If I take 1x from x squared, I'm left with 3x here. Now, I took a 2x out of both the numerator and denominator on purpose because I know that this will cancel with this. And this expression will simplify down to be x squared minus 3 over 3x. Now, you might be wondering, well, how do I know if I completely simplified it? And the only way you can tell is by looking at all of the different parts in the problem and making sure there are no other numbers or variables you can take out of all of them. So x squared minus 3, I don't see any common coefficient numbers. 3x, there's nothing you can do because this x here does not have a 3 or anything, any multiple of 3. So I know that they're all considered relatively prime. There's nothing I can do there with that. And then there's no other number of x's I can take out from all, so I know it's fully simplified. These problems, again, are asking you just to simplify the expressions. They're not asking you then to find the domain, but if they did then ask you that, you would look for when the denominator was equal to 0, but for now we're just simplifying. All right, letter C, a little bit different. Letter C, now we have 3xy plus y squared over 2y. And we're trying to pull out the greatest number of variables and greatest number of coefficients that we can. So looking at this example here, I see 3, and I don't see any other numbers in the numerator, and I have here 2 in the denominator. There's no GCF for the coefficient numbers that I can take out of all 3, so there's no number I can take out of all. Now looking at the x's, I see only an x here, and there's no other x's, so I can't take an x out of everything, but I can take a y out of everything. There's one y here, there's y squared here, and there's one y here. So the only thing I can do is take out a y from all of the terms in the numerator and the denominator. And when I do that, I'll be left with 3x plus y. And the denominator, when I take the y out of 2y, I'm just left with 2 here on the denominator. When I factor out the y from both the numerator and denominator, I can then cross these off since they cancel out. And this expression simplifies to be 3x plus y over 2. One way to determine that your answer is simplified is by looking at all the parts in the numerator and denominator, making sure they don't share any common variables amongst all of them, and or any common coefficient numbers amongst all of them. Okay, and then letter D is the most difficult and challenging problem that we've seen so far in this section because it's asking us to take out all of the factors that we possibly can from the numerator and denominator, which in all of the 3 we did so far, we're just basically using the greatest common factor method. As soon as I see this numerator being a trinomial, x squared plus 2x minus 15, I realize I can't take a common factor from all 3, so I should probably be thinking to try a different method, and that would be factoring the trinomial, like what multiplies to be negative 15 and at the same time adds to be 2. So what multiplies to be 15, I have 1 and 15, 3 and 5. Since it needs to multiply to being negative 15, I know that one of them has to be negative, one of them has to be positive. So the way to get a 2 from that would be a negative 3 and a positive 5 factor. So x squared plus 2x minus 15 factors to be x minus 3 times x plus 5, which is different than all the other problems we saw so far. This is the first time we're factoring the trinomial like we did in the last section. And then the denominator, 3x minus 9, the only thing I can do with that is take a 3 out of both terms. When I take a factor of 3 out, I'm left with x minus 3 like this. Now, once I have it factored, you can then start canceling things out. The only way things cancel out in fraction form is if they are in factored form, which shows multiplication. Like, X minus 3 here can cancel with this X minus 3 here only because everything is factored in a multiplication type of setting. So this would simplify to be X plus 5 over 3, since there's one X minus 3 on the top and one X minus 3 on the bottom. But I don't want you to think that if you ever had something like this, that would mean that you could cancel out that X squared and that X squared. That does not work like that. The only way you can cancel things out in fraction form is if they are being multiplied. If they're factored, is meaning that those different terms are being multiplied. So if you ever see the same thing on the top and bottom, but you see like a plus sign somewhere else, they cannot be canceled out. The only way you can cancel things out in fraction form is if everything in the fraction, in the numerator and denominator, is being multiplied. So what I want you to do, please, is try 1, 2, 3, and 4. I do understand that these are difficult. I want you to ask me questions. We'll go over the answers to these. This will probably take us to the end of class. So try your best on these. Each problem is different. It requires a lot of problem solving, a lot of thinking, and sometimes trial and error, and that's okay. So I'll give you some time. Anyone at home, please send me a chat if you're confused. Everyone here, ask me a question. We'll go over the answers, and most likely that will bring us to the end. Problems over here. We're looking at 24 and 16. The biggest number I can take out of both of those is 8. So you'll factor the numerator and denominator by taking an 8 out. And then also I see x, z is the fourth on the top, and x to the third, z on the bottom. Yes, you can take 8 x, z from the top and bottom, exactly. So that one here. There's like nothing else. Yeah, exactly. That X minus 6 will cancel out the top X minus 6 and yeah. Exactly. Yeah, exactly. It's strange because we haven't really been doing that. That's exactly right. One thing to note as you're working through these, sometimes you're not taking the greatest common factor out of everything. Sometimes you end up only being able to take like one x out, even though in the past you would try and take as many as possible. Don't forget this would be y squared plus 1. So then the final answer will be plus 1. That's right. Great, so let's go over these answers and see how you did. So for number 1, we are taking out the greatest common factor that we can take out of everything. So you have to look at the numerator and denominator consecutively at the same exact time so that you can figure out how many factors you can take out from the coefficients and all of the variables. So I see 24x z to the 4th, 16x cubed times z. So from 24 and 8 or 16, I can take an 8 from both of those, so I can kind of set it up as a fraction still. I'm going to take an 8 from the top and bottom. Looking at the x's, I can take one x out of x and x to the 3rd. And then looking at the z's, I can take one z out of z to the 4th and z to the 1st. When I do that, you then have to, in parentheses, put everything else that still would need to be there to make it still equal to the original. So if I take an 8 out of 24, I have a 3 here. I take the only x out, so there's no x's left. I take one z out of z to the 4th, so I'm left with z to the 3rd here on the inside. And then I take an 8 out of 16, I'm left with 2. I take one x out of x to the 3rd, so I'm left with x to the 2nd power. And I take the only z out, so there's nothing else there. So then once I complete that process, then everything that is the same in the top as it is in the bottom cancels out. So 8xz will cancel out with 8xz, and that's because everything is being multiplied. You can cancel things out when they are being multiplied. Then your final answer will be what's left. It will be 3z to the 3rd power over 2x squared. You can verify that that's simplified by looking at the coefficient numbers. You shouldn't be able to factor any other numbers out. And then looking at the variables, you shouldn't be able to cross anything else out. Number 2, looking at the coefficient numbers, 8, 4, and 20. The GCF, the biggest number that I can take out of all 3 of those, would be 4. So I'm going to set it up as having 4 taken out the top and 4 of the bottom. And then looking at all of the x's, I have x to the 3rd power, x to the 2nd power, and then 1x on the bottom. I can take 1x from everything in the top and the bottom. Then rewriting everything you're left with, I would have here, if I take a 4 from 8, I would have 2. And I'm taking 1x out of x to the 3rd power, and I'm left with x squared. Plus, I'm taking the 4 out of 4, I'm taking 1x out of x squared, and I'm left with x. Now notice, if we were actually factoring this separately and this wasn't a rational function, the real GCF of that would be 4x squared. But because now we're looking at the denominator as well, and you want things to cancel out here, you're not going to always factor it completely. Sometimes you have to factor it only as much as you can so that the bottom cancels out as well. If I take 4x from the 20x in the bottom, I'm left here with 5. And I can cancel out this 4x with this 4x, and I'm left with 2x squared plus x all over 5. So that would be considered simplified if you were looking at this and thinking to yourself, well, I can kind of factor this more. You, I guess technically could write this as x, parentheses, 2x plus 1 over 5, but not one is more simplified than the other. They're both considered simplified. This is simplified. This is just simplified in factored form. Okay. Number 3. 3xy squared over xy squared plus x. So there's no number that I can take out of all of them. Let's look at the x's. I can take 1x out of all of them, and I can take no y's out of all of the terms. So notice there's a 1 term at the top, 2 at the bottom. You have to look at all 3 in order to find the GCF that you can take out of everything. So I can only take an x from everything. So I'm left with 3y squared at the top, and I'm going to be left with y squared plus 1 at the bottom. Remember, if you ever are taking the variable completely out, you have to put a 1 there to keep its place. So then the x's cancel. The simplified expression would be 3y squared over y squared plus 1. And I do just want you to realize, I know I see a y squared on the top and a y squared on the bottom, but those do not cancel out. And the reason why they don't cancel out is because the bottom has this plus 1 here. The order of operations says you you can't do, the order is parentheses, and then we're going to have exponents, multiplication, division, addition, and subtraction. You can't do this division until you would take the y squared and then add the 1 to it. So because of that, you wouldn't be able to cancel the y squareds. So that would be the final answer for that one. And then number 4, we have to factor the numerator using the trinomial method. So what multiplies to be positive 36 and adds to be negative 12 would be double negative 6's. The denominator cannot be factored. It's just x minus 6. When you do have that, though, it's just one plain x minus 6 like that. It's still considered being in its own separate term here. So what's funny about that is, like, you can cancel this x minus 6 with this x minus 6, because technically it is like 1 times x minus 6. And then when one of them cancels with the other, you're left with just x minus 6 as your final answer.